Hey there. So in today's video, we'll be going through projectiles. So projectiles is one of the topic that comes across a lot of different subjects such as physics, maths. So it's a very, very useful thing to know. This will be the shortest video out there that covers both, covers everything for projectile. So stay tuned and let's get through it. So projectile is made of two different topics. So in this case here, let's have a look. So projectiles is when you throw something, so and it has a projection of the way they travels. So you have horizontal projectile projected when you throw something horizontally, and then it has the normal path and it hits the ground. Or the second scenario is when you throw an object at an angle. In this case here, someone is throwing a basketball at 30 meters per second at an angle of 35 degrees, and that would be the path of it. So these two cases are the scenarios that you need to be aware of and you need to be familiar in order to have all the basic skills to solve any type of projection questions, okay? So we're going to make this very nice, very easy and simple. So stay with me. So let's have a look. So first of all, it's very, very important to remember any projectile questions, there are two components that we need to break down the question into every time. Any projectile questions, you apply the same methodology. And that is, we have to separate it into our vertical component and into our horizontal component. So the vertical component, we've been working with something very similar with it in the previous chapter, especially when you've been using SUVAT. So when you throw a ball up in the air directly vertically upwards, so that would be your SUVAT equation. So we're going to be applying that for our vertical component. So and we know that in our vertical component, our acceleration is g, which is 9.8. Or the other scenario is when you throw something, is the horizontal component, and the horizontal component, the acceleration is 0, because in an ideal world where air resistance doesn't exist, we expect our object to travel at a constant speed. And if an object is traveling at a constant speed, that means it's not accelerating. And therefore, there's only one formula that you need to be aware for that, and that is speed is equal to distance over time. So in the horizontal component, you're only worrying about those three components: speed, distance, time. Whereas in the vertical component, there are 5 component variables you're looking out for, which is displacement, initial speed, final speed, acceleration, and time. So now let's have a look at some of the questions that we can do. So this is the first example that we have here. So let's read it out. So a particle is projected horizontally at 25 meters from a point from a point 78.4 meters above the horizontal surface. So the first part is telling us to find the time taken for the particle to reach the surface, so to reach the ground in this case here. So now let's have a look at the diagram. So this is how the diagram should be looking like. So you're throwing an object from up here, and we know that it's 78.4 meters above the ground, and when you throw it, the horizontal speed is 25 meters per second. So as I said earlier, there are two components you always need to break down this question into, which is the vertical component and the horizontal component. So let's have a look at that. So I'm going to write my vertical component and my horizontal component. So in this case here, my vertical component, as I said, is SUVAT. So I'm going to write SUVAT. So now we're going to substitute everything in. So in the vertical component, what's my displacement? So from the start point to the end point, my displacement is 78.4 meters. That's why I travel. What's my initial speed? The object is thrown vertically. Sorry, the object is thrown horizontally. So that means vertically, initial speed would be 0. Do I know the final velocity when it hits the ground? Not sure, so I'm going to leave it blank. And what's my acceleration? In this case, is the acceleration with the gravity, which is 9.8 meter per second squared. And what's my time? The time taken, that's what I'm trying to work out. So I'm not really sure what that is at the moment. But that's everything that we know. So horizontally, so I have 3 components, which is my speed, distance, and time. So let's have a look at all those 3. So I know the speed is going to be 25 meters per second. That's the speed I'm throwing at it. So it'll be 25 meters per second. Distance, I'm not sure. So at the moment, the distance is x meters. And time, I'm not sure either. So I've not been given. So from here, we know that horizontally, we're simply using the formula speed equals distance over time. However, because we have two unknowns, we cannot use or cannot do anything horizontally. So we must look at it from the vertical perspective. So in the vertical perspective, we have two items missing. However, remember the Suvert equations. Each equation has there are 5 different equations, and each equation has one of the variable missing. So in this case, in order to do part A, I need to find a Suvert equation that allows me to find the time, but has no v component in the equation. And this is a very straightforward one, and that simply is s equal to ut plus a half at squared. So if I substitute the values in this case here now, that will be 78.4 meters is equal to 0 times t plus a half times 9.8 times t squared. So it's going to be like this. And if you rearrange it from there, so that will give us a half times 9.8 squared is going to be 4.9 t squared. And then I bring the 78.4 to this side here, so become minus 78.4 is equal to 0. And once you rearrange into this format here, you can put it in a calculator straight away, and you should get the value of t as equal to 4. So the object takes 4 seconds from the starting point to reach the end. So now I can go back into my diagram, and then I can, I'm trying to get the pen here. So then I can go back to my diagram and now label it that my time is equal to 4 seconds. And I can do it on both sides. So I know that it takes 4 seconds to do that. So now part B is telling me to work out the horizontal distance traveled in that time. So the horizontal distance is finding the value of x. Now if I look at horizontally, I know my speed, I know my time, and therefore I can find my unknown, which is the distance. So I know the speed, I'm going to s is equal to distance over time. So if you rearrange this equation to make distance the subject, so distance becomes speed times opposite of dividing by t is timesing by t. So distance becomes equal to speed times time. So that will be 25 times 4, and that gives us an answer of 100 meters. So we know that the horizontal distance traveled will be 100 meters. And then part C is telling us to work out the horizontal, the distance of the impact point from the original point. And in this case, we are talking about this distance here from where we started to where we are ending at the end. So therefore, that is simply Pythagoras. We can see that's a right angle triangle, and we know the two sides, so we can find the hypotenuse. So therefore, let's call this side, let's say D. Again, maybe should have used something else, but if you use D, that will be equal to square root of 78.4 squared plus 100 squared. And therefore, if you put this in a calculator, it gives you an answer of 130 meters to 2 significant figures. And that is pretty much it. So again, guys, every time you do a question like this, remember, break it down vertical component and a horizontal component. Horizontal component, if you have two unknowns, that means you must start vertically and try to find something that you can pass on to that. And that is usually the value of time, which is common across both side of it. All right, so that's the first question done. Nice and easy, straightforward. So let's have a look at the second component. And the second component is knowing projection at an angle. Now we are throwing this object at an angle, not horizontally anymore, at an angle. So therefore, using the speed and the angle, we need to find the vertical component and the horizontal components when the object is started. So if I show you how the object travels, that's the way the object is traveling at the moment. So in this case here, the only thing that we need to do is break down this value. So here we have a right angle triangle. So if you look at this right angle triangle, we have this as the hypotenuse. That's our opposite, because the opposite of the angle of interest. And then we have our adjacent here, which is between the angle of interest and the 90 degree. So if you use SOHCAHTOA to try to find O and A, so therefore we know that for O, that would be sine x is equal to opposite over hypotenuse. So therefore this becomes sine 70 is equal to my opposite, which is O, over my hypotenuse, which is 20. And therefore you can rearrange this to make the opposite the subject, which is 20 times sine 70. And therefore that will be the value of my vertical speed, which is also going upwards. And then if I find my adjacent, which is very similarly done by using cos x is equal to adjacent over hypotenuse. If you substitute the values in this case here, so that'll be cos 70 is equal to my adjacent over my hypotenuse, which is 20. So therefore in this case here, that adjacent becomes equivalent to 20 cos 70. And therefore we split the speed into the vertical component and the horizontal component, which is all you need to do in order to do the question. And apart from that, you can take these two numbers, the two components we calculated, and do the question exactly the way that we did earlier. One small hint here, so that you need to be aware of, that's part of the knowledge you need to remember, is when an object reaches the highest point, then we know that the final velocity of that object at that point is going to be equal to 0. So in this case, if you have this object and this object started going from here, start traveling from here, if you look at the vertical axis, so a 20 times sine 70 speed, and therefore you know the final velocity here, v, will be equal to 0, and you can use that to try to resolve your question. So we're going to have a look at an example on that. So moving on to the next question. So the next question again is asking us here to calculate a few things. So a particle P is projected from a point O on a horizontal plane with speed 28 meter per second with an angle of elevation of 30 degrees. After projection, the particle moves freely under gravity and strikes the plane at a point A. Find the greatest height above the plane reached by P. So at this point here, the velocity will be equal to 0. The velocity vertically will be equal to 0. And we can find the time and the distance OP. So in an exam, you might not get the question, a diagram with the diagram. So, and therefore it's important that we're able to do it. So someone is saying that he's throwing a particle P from point O, which is on the ground, and is throwing this object at an angle of 30 degrees with speed of 28 meter per second. And then this object travels, and then it comes back down and hits the ground at the point A. So as I said, let's straight away calculate our values in this case here. Let's break this question down. So we have our vertical components and a horizontal component, in this case here, horizontal and then vertical. So let's try to find what that will be. So I'm going to speed up the process here a little bit. So if you find the vertical using the sin x value from the SOHCAHTOA, so that will be 28 sine 30, and this one here will be 28 cos 30, just by following the SOHCAHTOA in this case here. So now, once I've done that, now I can do my vertical component like I do usually, my vertical component and my horizontal component as I do any question. So horizontal is going to be speed, time, and distance. So what do I know here? I know my horizontal speed is going to be 28 cos 30. Do I know my time? I'm not sure my time. Do I know my distance? Not sure either. So I know that I cannot use anything from there. So now on the other side, I have my SUVAT. So let's calculate this. So I need to find out in the vertically the greatest height when it reaches the greatest height. So I'm not sure what that height that will be, but that's what I'm trying to calculate. The initial speed, we know that's going to be 28 sine 30. Vertically, vertically, the final velocity will be equal to 0, because we said when an object reaches the greatest height, the vertical speed will be equal to 0. Acceleration, because we are traveling against the acceleration, that will be negative 9.8. Essentially, you can also say that we're resolving upwards as positive. And my time from there, I'm not too sure what that will be. So in order to do part A, I need to find an equation using all the information from the vertical component where it does not involve time. And therefore, that would be simply v squared is equal to u squared plus 2as. So if you substitute everything in there, so that would be 0 squared is equal to my u squared, which is 28 sine 30, all squared, plus 2 times a, which is minus 9.8, times my s, which is I'm trying to calculate in this case here. So when you take this to the other side, so that will become minus 28 sine 30. Again, put the minus on the outside, squared. That will be over 2 times minus 9.8. That will be equal to s, and therefore your s in this case is equal to 10 meters if you put this in a calculator. So moving on from there to part B, which asking us the time of flight of P. So the time of flight is how long does it take to go from point O to the point A. So that's the whole journey in this case here. So we just simply need to adjust a little bit our vertical axis. So I'm going to redo this vertical axis using a different color pen again, I'm going to take my upward still as positive, and if I do my vertical axis in this case here again, so I still have my suvat. The reason why I'm restarting again is because previous question I was using the information for when it reaches the maximum, when it's reaching the maximum height. Now I'm calculating the vertical information when it reaches the point A. So because I start from the same point and I end the same point vertically, because in this case here I'm coming at the same point as starting point vertically, so that's why my initial speed, my displacement altogether will be equal to 0. My initial speed does not change, still going to be 28 sine 30. My final velocity, I'm not sure at what speed I'm hitting the ground, so I'm not going to put that in. My acceleration is still going to be minus 9.8 because I'm still starting my journey by traveling opposite of the opposite way of the gradient, and my time is what I'm trying to find. So using this information here, I need to form an equation that allows me to calculate the time that does not involve the final velocities. We've been through that, something like that very similarly earlier on, and that would be s equal to ut plus a half at squared. So in this case, that becomes 0 is equal to 28 sine 30 t plus a half times minus 9.8 t squared. And therefore from there, if you simplify a little bit down further, so that a half times minus 9.8, so that gives, 9.8 gives us minus 4.9 t squared plus 28 sine 30 t is equal to 0. And if you put in a calculator from there, you should get two values for t. So t is equal to 0 or t is equal to 2.857, which runs up to 2.9 to two significant figures. So you might be asking, what does this mean? So t equal to 0, that's also correct. So t is equal to 0 at the beginning here when he's starting the journey, because we're putting s equal to 0, so that could be at two different points. And at this final point here, our t is equal to 2.9 in this case. So, and that would be the answer for the time in this case. So now I can go to our horizontal component for the last part, which is asking me the distance of OA. So that's my horizontal distance. So I know my time now is going to be equal to 2.857. Guys, just make sure that whenever you putting the time or using the time, you're not using the rounded up answer, but using the actual answer to 3-4 decimal places. So it's going to be more and more accurate. So part C then, in this case here, again, I'm starting with speed is equal to distance over time. So again, I'm trying to find my horizontal distance. So distance is going to be equal to speed times time. So my speed in this case, horizontally was 28 cos 30. Time is my time that I just calculated right now, which is 2.857. I'm putting in 3 decimal places, but you can add more if you want to. And therefore, that gives us an answer of 69.282 ... and that can be rounded up to 69 meters to two significant figures. And that's it, guys. This is the second question done. Hopefully now you can see the difference between when you throw something horizontally and something vertical and something at an angle. Apart from you working on the vertical and the horizontal component of it, you can apply the same concept across the two questions. As I said, the main important thing is find the vertical component and the horizontal component. Always rely on that, and gives you a visual representation of what information you have and what you need to do. So horizontal, again, you need you have to know two variables in order to find the third missing one. So if you have two missing variables, then you know that you must start with the vertical component, and you work yourself around that and to try to get information that helps you to find values for the horizontal component, which in this case, let me add it, will be 69 meters. Moving on to the next part. So, and just to wrap up this video, hopefully you find this video helpful. I think it just went a little bit longer than expected, but essentially, if you can understand these two concepts very well, you should be able to answer any projectile questions. But my advice to you guys will be practice question from the textbook, or find some exam style questions to consolidate the materials that you learned from this video. Find any weaknesses or where you lost marks, and once you find them, make sure that you revisit those, make sure that those weaknesses becomes your strength, and then after that, practice one more question very similar to that, just to make sure that you learn from the mistake and you're not making the same mistakes again. And essentially repeat this first 3 steps as many times as you can, and the more time you repeat it, the much better you're going to develop your understanding of the content. Hopefully you find this video helpful and useful. If there is any specific video you would like me to make next, I'm more than happy to do that. Let me know in the comments below. And yeah, stay tuned. There will be lots of content coming out every day. Do let me know if there's anything specifically that you like to see. But yeah, I appreciate all the support. Thank you.